Welcome, everybody. Thanks for joining the Extreme Performance Series. My name is Achtemichuk. I'm your host today. And with me, I have Todd Muirhead. Todd, what are you going to be talking about today?
Yeah, Mark. So I'm going to be talking about monster database performance, which is a topic that I've talked about at VMworld several years in the past. We've got some new data to talk about today.
Awesome. So let's let everybody know a little bit about your background. What have you done at VMware here, Todd?
Yeah, so I've been at VMware in the performance engineering team for about 12 years now. And during that time, I've spent almost all of my time doing database performance, SQL Server, Oracle, MySQL, SAP HANA, all those different things, different databases on our platform, and measuring the performance, validating it in a variety of different ways, coming up with best practices about how to do it, and then communicating that information out to our partners and customers. So trying to improve the experience and also improve the performance itself on the back end by working with our development teams.
Well, that's awesome. And now, correct me if I'm wrong, but you're also one of the secret creators and maintainers of DVD Store. Is that right?
Yes. So DVD Store is an open source database that myself and Dave Jaffe, we first open sourced back in 2004 when people actually still bought DVDs in the store, believe it or not. And it was a real thing. So that's why the name is DVD Store. But it's an online store, so it simulates people coming in and purchasing things, browsing, submitting reviews, reading reviews, all the things you typically do in an online store. And we use it for database. So it supports different databases: Oracle, SQL Server, MySQL, and soon to be Postgres as well. And it's used by myself, obviously. Also, there's lots of other teams within VMware that use it for different performance tests. It's part of VMmark, for example. Then also people out in the industry have used it at different companies as well. So you'll see it if you're a database nerd like me. You'll see it used for different database tests from time to time, different white papers.
And I think databases are kind of interesting too, right? We spend a lot of time on them because they're one of those interesting workloads that exercises so many things at once, right? It's got to be good at compute. It's got to be good at I/O. There's the network tiering of, clients to it. And so that's always an interesting platform, right? I think that's why you spend a lot of time focusing on database, because in the past it has been challenging. It's not so much anymore. But what are your thoughts around database?
Yeah, so you're exactly right. Back in the ESX 3.x timeframe, we were still growing up to being able to really host databases successfully. And then by focusing on that in the subsequent releases, working closely to improve our performance as a platform to support databases, that meant that we had to work on all the different aspects that you talked about: CPU, compute. CPU and compute's the same thing. CPU, disk, network. It's all part of achieving good database performance. So that's one of the reasons why I like working on it. You end up touching all the different aspects, and it's a good workload for us to use to validate the overall performance of our systems as well.
Awesome. So you have some data to share with us today. What do you got?
Yeah. So in the past, like I said, well, not in the past. My topic has often been monster databases, where we take the absolute largest size VMs that we could create and do some performance tests. And that was typically with 4-socket servers. Today, I'm going to show you some data with 2-socket servers, because the 2-socket servers themselves have grown so powerful now that we can run monster VMs on them as well. So let me, I've got just a few slides. I know that slides can be a little tedious. I've got a few slides that I'm going to share to help me kind of step through the data here. So let me bring that up. This is a slide that I presented back at VMworld 2019 with the 4-socket servers going all the way back to Westmere with 40 vCPUs. And at that time, Westmere was a 4-socket server that only had 40 cores total on the box, or 10 cores per socket. And then we worked our way up over the years, all the way up to Skylake with 112 vCPUs, 112 cores in the system. And on these tests, we're basically creating a single VM that takes up the whole host, which is kind of a cool, nerdy thing to do. It's a good performance test. It allows us to really stress our platform and validate that, yes, we can run really big databases on the host. Now, it wasn't really my expectation that a lot of customers would be doing this scenario, right? Taking a single large VM and using up a whole host. But it was meant as an exercise to show that, yes, it is possible and we can achieve good performance even with these really large configurations. So the things that most customers are actually doing, it's going to work fine. We're going to be able to support the performance for those size databases. Okay, so this, like I said, is kind of historical 4-socket. The new data that I wanted to share with you guys today is 2 sockets. So this is a 2-socket server, an AMD EPYC 3rd generation or Milan server that has 64 cores per socket, or 128 total for a 2-socket host. So you'll notice this slide looks really similar to the previous one, and even the vCPU counts along the bottom are kind of similar in a certain way, but this is going up to 128 in a 2-socket server, right? So we're able to achieve the performance, with only a 2-socket server.
And so we're really kind of seeing a little bit of the resurgence of AMD too, right? We've done a lot of Intel work, and it's nice to see, obviously, that other platform here as we've kind of optimized vSphere to take advantage of its unique architecture.
Yeah, so and that's exactly what's happened. They've come out with a different architecture that allows them to get a lot more cores per socket. And the way they did that is with these Zen, what they call the Zen architecture underneath. And so the layout of the caches is slightly different than the way Intel does it. So we went and optimized our scheduler in order to be able to take advantage of these differences more efficiently. And so starting in the vSphere 7.0 U2 release, there's an update to our scheduler that gets a little bit more performance out of these boxes. So if you're using AMD EPYC systems, I'd highly recommend that you think about using 7.0 U2 as a starting point if you want to get the absolute best performance out of them.
And you have a white paper on that we can reference below too, is that right?
Yeah, yeah, exactly. So associated with this video, I'll post links to the white paper. It's not just my white paper. I do have some data in the paper, but it was done by a team of engineers, actually 4 or 5 of us that did different testing data points on it. But yeah, I'll link that for sure.
Awesome.
So moving on to, so that was a scale up test. This is what I call a scale out test. So multiple VMs running on a single host. And this is also just the latest generation Intel processors. So this is a 2-socket Intel system that has 40 cores per socket. And in this case, I did a comparison against the previous generation, which was Cascade Lake, which had only 24 cores per socket. So you can see that we're running, all the way at the end there, we've got 8 vCPU VMs all running on a single 2-socket server and achieving good performance as we've scaled up from the single VM to 2 to 4 to 8 to 10. You can see as we go across. So I think in this scenario is a little bit more likely what most customers are doing, which is running multiple database VMs on a single host as opposed to just one big VM. And again, we're achieving great performance with big gains over what we were able to achieve with Cascade Lake, just the previous server generation before. So as you get these additional, these new generations of servers with new processors and additional cores, using vSphere as a platform, you can get that performance for your databases, is what this shows. Whether you do scale up or scale out, the performance is great. And like I said, this is multiple VMs. The previous one was a single VM. You can do either one, and you can get good performance.
Well, that's awesome. Again, talking about the vSphere platform, I mean, that's really the idea here is we can support large workloads, we can support many workloads, we can support those workloads exercising everything. So really need to see the database performance and track that over time. So thank you, Todd, for sharing that with us today. Totally appreciate that.
Yeah, great. And I want everybody to check out all the associated links that we're going to have. There's a lot of best practices that are very detailed documents that go into exactly how to achieve the best performance. So obviously not going to get that out of this short video, but the links below will provide you all the details that you need to achieve your best performance.
Awesome. Well, thanks everybody for joining us today on the Extreme Performance Series.